If you feel like your network performance is a little bit low and your switch's hardware usage are abnormally high, so follow me as I will show you how to literally tune and optimize your VLAN links in an SDP. So my question is, what is exactly pvst? If you're working in a small or medium-sized business, you definitely have several switches and you probably have a number of VLANs. If you're very concerned about your uptime, you may connect the switches to each other to have a redundancy and backup. However, without tuning SDP, your network performance is negatively affected and you can't use the maximum of capacity. That's exactly the moment that we need pvst. Per VLAN spanning tree protocol, which enable us to use every single link to transfer data among the VLANs. In addition, RAM and CPU usage in switches are going to be decreased. One of the biggest reasons that we have to tune pvst is pvst prevents having traffic congestion. Now, the question is how to do that? Well, you can easily change root bridge for each VLAN to be able to use maximum of capacity. Alright, let's get started with the laboratory. Alright, this is our scenario here. We got 3 switches and we have 3 VLANs, VLAN 10, 11 and VLAN 12. As you can see, we connect the switches to each other to have a redundancy, and port fast Ethernet 23 down here is blocked by SDP, right? Basically, for each VLAN, we have one SDP, so we got 3 SDP in this topology. But the problem is, let me open switch 1 here, which show spanning tree. You can see the information. Alright, VLAN 10, as you can see, this is a bridge. This is a root bridge. For VLAN 11, as you can see, this is a root bridge too. And for VLAN 12, this is a root bridge. So, switch 1 is all of the VLAN's root bridge, right? And because of that, one physical port fast Ethernet 23 is entirely blocked, right? As a result, we can't use maximum capacity, and this may happen traffic congestion. Let me show you the road that the packets are traveling, guys. With simulation here, I want only ICMP, guys. I'm gonna test from PC VLAN 10 in here with ipconfig. You can see the IP, which is network 10. I'm gonna ping another PC in switch 3, 192, 168, 10, 12, IP 12, right? Alright, let's get started. As you can see, the packets are going through switch 1 and then reach to the destination, switch 3 and PC VLAN 10 with IP 12. And the packets are coming back. Now let's capture the ICMP packets for VLAN 11. I'm gonna ping 100, 168, 11, 12. We're pinging this PC, VLAN 11 with IP 12, with host ID 12. And if I ping that and simulate only ICMP. If I ping that, let's see what happens. Alright, it goes through switch 1, right? And then reach to the destination in switch 3. And port fast Ethernet 23 is entirely blocked, guys. So we cannot use the maximum capacity. So the question is, what's the plan? It is to change the root bridge for each VLAN. I prepared some banner here. So we're gonna change the root bridge for VLAN 10. Oops, sorry, VLAN 10 is already belong to the switch 1, right, in here. And we change the root bridge for VLAN 11, it's gonna be switch 2. And switch 3 is gonna VLAN 12 root bridge in here. You can easily do that, guys. I'm gonna show you. So it is already switch 1 is root bridge for all the VLANs in here. So I'm gonna start from switch 2. As the banner says, let me show spanning tree first. Spanning tree, let me see. With spanning tree VLAN what? For switch 2, VLAN 11. VLAN 11 and root with primary. Now the VLAN 11 root bridge has changed. Let me figure out that the VLAN 11 root bridge has changed successfully. Let me see. With show spanning tree. Now here, VLAN 11 is belong to the switch 2. Now it's time to change the root bridge for VLAN 12. Enable conf t and spanning tree. As the banner says, VLAN 12 root primary, right? And right. It's supposed to be root bridge for VLAN 12. Show spanning 3. Now the root bridge for VLAN 12 has changed successfully. Now let's check out the changes that we did. Start from switch 1. Show spanning tree. VLAN 10. Both trunk interfaces are designated in forward. And for VLAN 11, port 24, which is connected to the switch 2, which the switch that we assigned VLAN 11 to it, is now root port. Interesting. And for VLAN 12, see, Fast Ethernet 23, this port, which is connected to the switch 3, the switch that is root bridge for VLAN 12 now, it is root port, right? And let's check out switch 2. Conf t. Oops, exit. Show spanning tree. Alright, for VLAN 10, the port is directly connected to the switch 1 is root port, right? For VLAN 12, the interface which is connected to the switch 3 is root port. And let's check out our switch 3. VLAN 11. As you can see, port Fast Ethernet 23, which is connected to the switch 2, is root port and forward. That is all set successfully. Alright, now I'm gonna capture the ICMP packets to make sure that all the links are being in used. Simulation again. I need ICMP. I start from PC with VLAN 10, ping 10, 12 in here. So the packets from PC VLAN 10 in switch 2 to see the PC VLAN 10 in switch 3, it must go through switch 1 to reach to the switch 3. Let me check out another link, VLAN 11. Let me see the road that the packets are traveling for VLAN 11 in switch 2. Before pvst tuning, this port, Fast Ethernet 23, was entirely blocked by SDP, right? And now VLAN 11 traffic is supposed to go through this link. I mean fast Ethernet 23 to reach to the destination in switch 3. If I ping this PC, let me see where it goes. The first action is the ARP, that the switch broadcasts the frame to figure out where is the IP. Here we go. It goes through the Ethernet that it was blocked before pvst tuning, right? Now you can nicely use all the links. But guys, let me tell you something. You can use pvst tuning until your network is not too expanded. But listen, it is strongly recommended that do not use pvst if the number of VLANs are more than, I don't know, maybe 20 or 30 because of the BPDU traffic. You should use another protocol named MST in an enterprise network. I hopefully make the video after this. Thank you for watching. See you soon.